Okay, so it's been 5 minutes and we're just going to test. You might remember this from the lab on pH. Just using some pH paper to make sure that we actually are. We have made the solutions of catalase acidic and basic. So here, test tube 1A. And usually I just try to get it down in there without dropping the whole thing. Get it mixed in there. Go back up. Woo! Right? And we'll see that this is, it's showing between about a 2 and a 3. Right? So now I'm going to make sure that there's nothing on these forceps. Okay. We'll test the 2A that we put water into. And there's basically, and no change between a 6 and a 7. Okay, so that's good, right? And then lastly, we'll look at where we put sodium hydroxide. Come on, there we go. Right, and in this case, we see that we've achieved a pretty, 12, 13 from our, just very simple Fisher brand pH paper. All right, so now we're going to go ahead and add the catalase and see what happens. So again, a pipette full into each one, and goes for 20 seconds. So here's 1A with the 1 molar hydrochloric acid. I'm going to add that, start the timer. Put these back in. All right. So in that circumstance, it looks like there's really, really nothing. Maybe 2 millimeters. It could just be artifact. It's just really very little of any reaction in the acidic. Again, a pH of about, we said between 2 and 3 with that 1 molar. So here's our 2A. So we're going to add and start the timer here. So, whoa, wow. That just went right to pieces.
Very fizzy.
All right, and so after 20 seconds of reacting, we see, we even went out, so we're probably at somewhere about 13 and a half or 14, but it's really gone beyond our test tube, so I usually tell students just go for add a plus to the number because you really can't quantify after it's outside the test tube. But clearly in excess of, in excess of the 13 centimeters to the top, so 13 plus centimeters. All right, and then lastly, we'll see what happens with a base here. Okay, so we're going to add hydrogen peroxide to this last one and give it a time. Well, stellar. All right, so here there is a reaction, but nothing like the normal or pH of 7. So a reaction of about 2.5 centimeters. Okay, so the pH here, if you recall from chapter 2 and the lab we did, pH is determined by the amount of free hydrogen ions in a solution, right? So when you have a low pH, you have a lot of free hydrogen in the solution, free hydrogen ions, all right? And those free hydrogen ions influence, again, one more time, like the temperature, the structures of proteins, like catalase, and they fall apart in these low pHs. If we talk about humans, this, of course, is one of the reasons you're going to die if your body's pH drops. And it doesn't have to drop very far, as we talked about in chapter 2 and in that lab on pH. It's acidosis is diagnosed when your blood pH is below 7.4, right? And you are generally dead by the time that pH hits 7. So just a small change in the amount of those hydrogen ions, right, increasing the hydrogen ions, will influence the activity of your proteins and your enzymes specifically. All right, so again, this one, here's our pH of 7, which is about right for a cell, okay? So again, if it's a blood, no, but a cell, yeah, a cell's pH is probably right around 7. In the case of the sodium hydroxide, we got some reaction, but again, here in a base or an alkaline solution, the problem is that you don't have enough free hydrogen ions, right? That's how you basically categorize something that's a basic or alkaline. It has less free hydrogen ions, and in that circumstance, again, by not having enough free hydrogen ions available, that also alters the activity of these enzymes. And so we call that alkalosis in humans, or in the circumstance where our pH of blood rises above 7.45. So again, excuse me, for humans it's below 7.35 for acidosis, and 7.45, if it's above 7.45, it's alkalosis. So we don't have a lot of room or margin for error, okay? And if your blood pH gets to about 7.8, you, again, will die. So the amount of hydrogen, free hydrogen ions in a solution is very important in determining the activity of your enzymes. And so one of the things that this lab is trying to illustrate is just that we have to consider why we have these environmental conditions or circumstances in which our cells exist, and that life exists, at least for humans, in a fairly narrow range. Now, other organisms have evolved for differences, right? So, but we lump them together in what we call extremophiles, and their abilities, their chemical reactions occur in different situations than ours. Also, inside the body, there are ranges of pH that can occur, but again, the blood pH is a pretty constant to go back to. So, you have a stomach pH that's somewhere between 1 and 3, but that's inside the container we call the stomach, not the cells and not the blood. So, I hope that this lab has given you some appreciation and for how the chemistry or biochemistry specifically functions. It's not a very detailed, it's not in depth, but it is, again, an introductory biology course. And I hope you are starting to ask some questions and think about why things are the way they are. Take care.